What's up guys, this is problem 104 of Neetcode with 50 palindromic substrings. So in this problem, it is quite similar to the previous one we just did, which is longest palindromic substring, where we had to find basically the longest substring that is a palindrome within the given string. Only in the next problem, or the one we are currently solving, we have to render how many different substring are palindromes, and a single character is itself a palindrome because a single character reverse is still that single character, right? So, for example, here we have ABC. So we can see that A itself is a palindrome, B is a palindrome, C is a palindrome, right? So we have an output of 3. If we have and A, we have basically A that is a palindrome of itself, second A that is a palindrome of itself, third A that is a palindrome of itself, and then we have the first two A that are palindromes of themselves, last two A's that are palindromes, and basically the three together that are a palindrome, grand total of 6. Alright, so we're going to use pretty much the same technique as the one we used for the previous problem, longest palindromic substring. And I will just go shortly on how we solve this. So what we did is that instead of going for every single characters, taking basically itself plus the next characters and checking if the inverse of that substring is equal to that substring, we will just basically use the observation that basically the middle of a substring that is a palindrome has a right value and a left value that are exactly the same. So what we will do is that we will just go see basically for each characters if its left and right values are the same. If it is the same, it means that we have another palindrome. So we're going to do this. And this is the case where we have a single value that is a middle. But we also saw in a previous problem that it is possible that we have something like B and B, in which case if you only take like one middle, for example 1B, and you go see its value to the left and to the right, you're going to see that you're going to have like a hey here, and then you have a B here, right? So that will make it look like it is not a palindrome, but it is actually possible to have like two two values that will be a middle, in which case, like for example here you can have two B's and the two next values are A and A, so you do have a long palindrome here of ABBA. So that's exactly what we did. We're going to use pretty much the same concepts for this problem, but instead of checking how many different palindrome we have, well, instead of checking the longest one, we're just going to add one to a variable we're going to call it results, that will basically take into account the number of results that we have. All right, so for example here we will have basically a long palindrome here. It's going to be ABBA. We're going to have another one that is BB. We'll also have basically every single character who are going to be palindrome of themselves. And that's it. So let's see the code. So this is the code for the previous problem. So you can see that we have a left and a right pointers. This is the solution for the single centers, and this is the solution for the double centers. They're quite the same, and the only difference is that for the double centers, the right pointers is going to be basically one index greater than the left pointers. And what we're going to do is that while basically we are in bounds, if basically the value to the right and to the left of the center are the same, it means that we still have a palindrome. So in this case, we in the previous problem, we just take a look at the length of that current substring, and if it was greater than the previous longest palindromic substring, we will set the longest palindromic substring to the current one we have. But instead of just checking if it is greater, we're just going to add one to results, because we know that we have another substring that we know it's a palindrome. So let's go ahead and solve this problem. So first of all, we will need results with an initial value of 0. And now we're going to go for every single characters inside the string that we are given. So I will say for, let's say I in the range of the length of our string, right? I will basically have, I will have another function that will basically count how many substrings we have for every single middle. So what I will just say is that I will append to this result the self that find poly. Okay, so to find palindromes. So in this function, we're just going to pass basically the string and the left and right pointers. So we'll do the same thing for the self that find poly. So I will do the same thing for the double centers. All right, so right here we know that we did two call for this function that we've yet to build, and we've basically passed two indexes. And you can see that for the first call here, we passed basically the same indexes, meaning that we're just gonna check every single centers for the single centers. So let me just single centers, and then we're gonna have double centers. All right, so now we are gonna build the function find poly, and in this function we know that we are gonna receive a string. We're gonna have a left and a right pointers, and what we're gonna do, we're gonna do pretty much the same thing that we did. So what we're gonna do is that we are just gonna check if we are in bounds, so if the left pointer is at least equal or greater than 0, and if the right pointer is smaller than n and is the length of the string, and also if the two pointers to the right and to the left are equal to each other's. And if this is true, it means that at that particular places we found another substring that is a palindrome. So we're gonna add 1 to the results. So let's go ahead and code this. So I will have a result here that will initially be equal to 0, and I will use my while loop while the left pointers is greater or equal than 0, and the right pointer is smaller than the length of the string that we're given, otherwise we are out of bound. And also if the left and right values, so string at the index of the left pointers and the string at the index of the right pointers, so if both are equal, it means that we have another palindromic substring. So what we're going to do is that we're just going to add 1 to the results, and then we're just going to keep going. So we're going to move our left pointer to the left, and we're going to move our right pointer to the right. And at the end of this, we are going to return the results. So that is a function. Now, basically for every single position, we are going to try to see if this is a middle. So we're gonna call find poly upon this particular index, and we know that basically at every single characters, well, the character itself, it's going to be equal to a palindrome, because on the very first call that we are calling this index, the string at the index left is the same as the string at the index right, because index left and right are exactly the same here, right? We're sending both I. We're also doing the same check for the double centers. For example, if we have a B and a B next to one another, well, we want to take that into account as a single center. So this is why we are passing that the left pointers is the index I, and the right pointers it is I plus 1. So we go basically scan for like 2 values that will account for a single center. Right? And find poly, we are just checking if we have a palindrome. So that is the entire algorithm. Let's check this out. It works. In terms of time and space complexity, well, first, the space complexity. Notice that we never created additional array or hash map, so we're going to have a space complexity of big O of 1. And in terms of time complexity, well, the worst case is that for a particular input inside our string, we're going to go see all the other inputs inside the strings. So this is basically going to be n times the length of the string, so it's going to be n times n, so n squared. So this is going to give us a grand total of big O of n squared, which I think is exactly what they're telling us to do. So yeah, the solution has to be as good or better than this. If you want to do better, you're going to have to use the Manacher's algorithm, which is quite more advanced, but for the purpose of this drill, I think that this is good enough. Well, at least it is far better than the raw solution, which implies simply looping through every single values and checking if it is a palindrome, which is going to have a time complexity of big O cube. With that being said, I hope you learned from this video, and I hope to see you in the next one.